Hey everyone, welcome back. Today we are exploring vertical sharding, a technique that splits your database column-wise rather than row-wise. If you want to separate different parts of a dataset into their own dedicated tables and servers, this approach might be for you. So let's see how it works. As always, we start with the what question. So, what is vertical sharding? In vertical sharding, you split columns of a database table into separate tables or shards. So each shard focuses on a specific subset of columns. For example, if you have a user table with columns for name, email, bio, followers, and tweets, you might place the user profile columns in one shard, the followers data in another shard, and the tweets in yet another shard, and so on and so forth. Each shard is now an independent table that runs on its own machine or server. As you can see here in this example, we have a table with name and email, and we put them one with the name and other one for the email. Okay, why this is important? What are the advantages of this architecture? I would say first, the query performance, like by having each shard dedicated to a smaller subset of columns. Queries that target only those columns can be faster and more efficient. Your system only touches the data it really needs. Number two, simplified queries. Like if you only need to fetch, say, user profile columns or maybe usernames, user email, you query just the profile shard rather than scanning a massive table with dozens of unrelated columns. What are the disadvantages? First, we have a potential for hotspots. Like if one shard holds columns that are frequently accessed, that shard might become a bottleneck. Other shards could be underutilized, leading to an imbalance in your system. Number two, challenges in your schema changes, like adding or removing columns can be quite trickier because those changes may affect multiple shards. You'll have to carefully coordinate any schema update to maintain the consistency. Okay, I guess the next question will be, when should we use vertical sharding? I would say first in distinct functional areas, like if parts of any entity, like user tweets versus user profile, are accessed independently, vertical shards helps isolate those workloads. Number two, large spare tables. If you have a table with numerous columns that queries typically only need a handful, splitting out less used columns could speed up things up. Number three, for performance isolation, you want certain columns like hot columns on a dedicated system for better performance control or more memory disk allocation. In these scenarios, vertical sharding can reduce overhead and streamline queries. Okay, what are the best practices that we need to follow? I would say first analyze your queries, see which columns are often queried together or really accessed, group them accordingly. Number two, monitor shard load, like keep an eye on each shard's resource usage to catch any hotspots early. Number three, plan for evolving schema. Understand how your data might grow or shift so you can adapt your shards without any major downtime. So, I guess that's it, and we can wrap things up. So, to wrap it up, that's it. Vertical scaling in a nutshell. By splitting your tables column wise, you can potentially boost performance, simplify certain queries, and better isolate workloads. But remember, watch out for hotspots and schema complexity that can arise. If you found this video helpful, please like, subscribe, and drop a comment about your experience with sharding. Until next time, keep optimizing those databases, guys. See you.